Hello everyone, and welcome to Chem 101. And if you're hearing this message or looking at this video, I'm still alive. Always want to say that. Okay, so as you know, the reason why I cannot be there at this moment is because my Form 6 is having their results being told. So I have to be there, and I forgot about this. So I'll make a video of basically talking about reactions of carboxylic acid. So at this moment, you should have gone through, we've gone through alcohol, reactions of alcohol, we've gone through reactions of alkene and alkane. So today I'm gonna talk about mostly carboxylic acids first, okay? So first of all, turn your books to page 108. And now typically acids have the reactions of acids we have learned in Form 4 is that when acid reacts with alkali, it gives out salt and water. Okay? So in this case, for carboxylic acids, so it has, for example, we'll take ethanoic acid. When ethanoic acid reacts with the common alkali, NaOH, so it will give us CH3COO negative Na positive and then plus water. Now you will notice that this representation, we usually use this in. Now if you don't like this one, you can also rewrite it as CH3COO Na. Now remember, this hydrogen over here deionizes, okay? So unlike HCl, okay, this hydrogen deionizes and combines to form H2O. Whereas for this case, this H will combine with this OH to form H2O, okay? So that's the first reaction with alkali. Now the another reaction we've learned is that even in the in the Form 4 is that reaction with hydrogen carbonates. Okay, so typically it will be NaHCO3. Okay, hydrogen carbonate, so there must be an H. So again, we'll take CH3COOH as an example. So reacts with NaHCO3. So since we have CO3, so it's the source of for carbon dioxide. So carbonate will form carbon dioxide. And then same as the top one, we'll have salt, water, and carbon dioxide. Okay? So now is this neutralization? Now remember, no, this is not neutralization because we have CO2 forming. So this one is neutralization. Okay, so neutralization is a process where only salt and water is only formed. Okay, so these two reactions are typical reactions we've learned in Form 4. Now, what about the new one? So the new one is the third one. We call it esterification. Esterification. Okay, now for esterification, as the name says, we will be forming ester. So now let's say we have a carboxylic acid. So main group of carboxylic acid is COOH, and we have alkyl group, okay? And then we need another source, okay? Which this one, I'll let you guess in a minute. So the product will be RCOO. We need to form ester, so we O and then R. This is R1 and R2. So they're long chains, okay? So you will see that over here, this is the signature for ester. So now we have acid over here. So you will notice that this COO and double bond and this CO. Now, if you remember, to name an ester, we have to cut it. So this place is the where we cut. Now, if you remember, COO is coming from acid. And this part is coming from alcohol. So know that we need acid and alcohol to form ester. So in this case, we have the acid. So now we need an alcohol. So what we do is just give an alcohol. So this is R1 and H. Okay. Now what happens is in esterification, this part and this part of H will be reacting. So these two will disappear. As you know, this is OH and H. What will be the side product? Yes, H2O. So what happens is that when this OH removes and then this H removes, so we'll have this. like this. So what we do, we just combine them, and hence we got the ester. Okay. Now normally this process, if we just add them together and wait for the reaction to happen, it is very, very slow. So to speed up, okay, this reaction, we add something. We add H2SO4, an acid. Okay. So basically, we're an acid to speed up this reaction. Okay. So esterification is also the type of reaction. Okay. It's condensation. Okay, what is the meaning of condensation? Now, condensation reaction is in a reaction in which two or more molecules react together to give a larger molecule with the elimination of small molecule, which is water. Now, the definition is on page 108. Do you have to memorize this? No. Okay, just know condensation is a process which two of them combine to form a bigger molecule, and H2O is released. So this is the type of reaction. So at this moment, we have learned addition. Okay, we have learned elimination, and the third one we have learned something new is condensation. So for addition, if you remember, it was for alkene. Okay, we added this. Elimination. No, we actually not talked about elimination yet. Sorry, it was substitution. Substitution reaction. So we've not learned elimination. So addition and substitution. So substitution was alkane, addition was alkene, and for condensation is these two parts. Okay. So for example, now usually how will they give you questions? So the questions will be given you like this. They will give you two reactants, an acid, carboxylic acid, and an alcohol. Okay, so let's say if I give you an acid will be CCC, propanoic acid, reacting with, let's say, a simple alcohol, ethanol. So we have CCOH. Okay, so if acid and alcohol, so you know that it will form ester. So remember, for ester, always draw COOH first, and then ask yourself, if I want to name this, I'll break this down here. So the one with COO will be coming from acid. The one from oxygen only will be coming from alcohol. So then you will always know where the acid is coming from. So acid has COO bond. So we just have to count how many carbons. So 1, 2, 3. So we have 3 carbons. So we do the same thing. 1, 2, 3. And then for alcohol, the same thing. So since this H will be gone, okay, and this OH will be gone. So we're only left with O. So how many carbons?